Hello, and welcome back to the video for lesson 1.3. This lesson is over data collection and sampling techniques. There are 5 different ways that we're going to learn about sampling in this lesson. And sampling is how we actually gather the data for the observations that we're going to collect. So a sample should have the same characteristics as the population it is representing. There are 5 different types of sampling. The first is a simple random sample, where any group of n individuals is equally likely to be chosen as any other group of n individuals if the simple random sampling technique is used. That's really the most ideal. Stratified is where you choose your stratified sample by dividing the population into groups called strata, and then you take a proportionate number from each stratum. I think of the stratified as kind of like a cake that has layers to it, where you're getting a little slice of the cake. So you're getting a little bit of frosting, a little bit of cake, a little bit of the jelly, a little bit of cake, a little bit of frosting, and so on. Cluster is almost the opposite of stratified. So in cluster, you divide the population into clusters that are already stratified, essentially. They're already randomly grouped from all the characteristics. And then you're randomly selecting some of the clusters, and all of those clusters, individuals, are going to be part of the sample. So in this case, it might be, clusters might be all of the psychology courses at Glen Oaks, because each of those classes in psychology, Psychology 100, we would say, has a pretty varied group of students in there, some from the business department, some from the math, some from the sciences, some from nursing. And so you're getting a little bit of every type of student in there. And we would randomly select one of the courses in Psychology 100 and sample everybody in that class. That would be a cluster. Systematic sampling is we randomly select a starting point and take every nth piece of data from a listing of the population. So for instance, if you're standing in line, waiting to get into a concert, and somebody from a energy drink company comes by, and every 10th person that they sample, they give a free drink to. So usually you'll be able to tell it's systematic because they talk about every 10th or every 15th or something like that. Convenience sampling has no structure. Convenience literally just means the results that are readily available. This might be if you want to gather data from Glen Oaks students, you just stand near the front door and ask students that come into the school whatever your question for your survey. So there's no real criteria of how you're gathering your data. True random sampling is done with replacement. That is, once a member is picked, that member goes back into the population and thus may be chosen more than once. However, for practical reasons, in most populations, simple random sampling is done without replacement. Surveys are typically done without replacement. That is, a member of the population may be chosen only once. Let's look at example 1. So we're going to go through example 1, and then I'm going to have you pause the video and try example 2 on your own, and we'll come back together to answer those. A study is done to determine the average tuition that San Jose State undergraduate students may pay per semester. Each student in the following samples is asked how much tuition he or she paid for the fall semester. What is the type of sampling in each case? A sample of 100 undergraduate San Jose State students is taken by organizing the students' names by classification, freshman, sophomore, junior, senior, and then selecting 25 students from each. Okay, this would be considered stratified because we're going to gather a little bit of a sample from each group of freshman, sophomore, junior, and senior, because it said 25 students from each. B, a random number generator is used to select a student from the alphabetical listing of all undergraduate students in the fall semester. Starting with that student, every 50th student is chosen until 75 students are included in the sample. So it started out sounding like it was simple random sample, but because they're taking every 50th student, it is considered systematic. B, a completely random method is used to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. That would be called simple random sampling, SRS. D, the freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4, respectively. A random number generator is used to pick 2 of those years, and then all the students in those 2 years are in the sample. So all students in those 2 years, so they're randomly picking, and so this is going to be considered cluster. E, an administrative assistant is asked to stand in front of the library one Wednesday and to ask the first 100 students he encounters what they paid for tuition the fall semester. Those 100 students are the sample. That is most definitely convenience. So I would like you to take a few minutes, pause the recording, and come back, and then we will look at example 2 together. Okay. After reading through A, B, C, D, E, and F, what do you think? So E is going to be our simple random sample. Every third in letter D is going to be our systematic. B, they picked 5 different high-tech companies and they interviewed all human resource personnel. So that's going to be cluster. Letter F, he just samples everybody in his algebra class. That's going to be our convenience on that one. And then A and C, I would give both of those the stratified. Because you're getting a group from each age group up here, and then C, you're getting 50 from the high school female teachers and the high school male teachers. Okay, example 3 is regarding sample bias. So sample bias can come in forms of different ways, and it's how you're taking the sample, okay? There's definitely sampling error, and that happens without being able to control it completely, but sampling bias you can control by the way you take your sample. So let's look at example 3. Suppose ABC College has 10,000 part-time students. We are interested in the average amount of money a part-time student spends on books in the fall term. Asking all 10,000 students is an almost impossible task. Suppose we take 2 different samples. First, we use convenient sampling and survey 10 students from the first term organic chemistry class. Many of these students take first term calculus in addition to the organic chemistry class. This is the amount of money that they spend on their books. The second sample is taken using a list of senior citizens who take PE classes and taking every 5th senior citizen on the list for a total of 10 senior citizens. And this is what they spent on books. It is unlikely that any student is in both samples, so that's important to know. A says, do you think that either of these samples is representative or is characteristic of the entire 10,000 part-time student population? And I would say no. For one, the, the first group of students are taking very high academic rigor courses where more than likely they're going to tend to have more expensive books. And usually the sciences, there's also other extra costs or fees associated because of the labs for the chemistry classes. And the second sample is definitely not representative of the entire 10,000 part-time population because they are senior citizens and they're only taking PE classes. So for one, they're going to tend to have lower book prices. And I would not think that the majority of your students are senior citizens. Oh, and that's not supposed to be good. Okay. Other question, is the sample biased? And I would say yes. And we just talked about why it's biased, because they did not have a random group of students that represented everyone. So it does not represent every type of student. So catch me back for a video for lesson 1.4.